The same way we used nodes to decide whether resistors are connected in series or in parallel together, we are able to use the nodes to recognize two different representations of the same circuit. So for example, right here, right now, I have this circuit here and this circuit here. Obviously, the representations are different, but they are the same circuit, not only because there is one power supply here, one power supply here, and three resistors on the left, and also three resistors on the right. That's not the only reason, but if you try to look at the node, so let's say this is the blue node that goes from the positive of the power supply to R1. This is its counterpart on the right side. If we go and take the other node, which is from R1 to R2 and 3, you can see that this is what I am referring to. So color-coded counterparts, basically. And then let's take the other node right here that goes all the way back to the negative of the power supply, which is partly this, goes to the power supply, and partly this. It is important for you to be able to recognize the pattern between the left representation and the right representation. Everything in blue, highlighted in blue on the left side, is the same as on the right side. And other colors are the same. So everything in magenta on the left is the same as on the right. And it is important to know this because sometimes you're going to see the circuit represented in one way or another way. So instead of you trying to figure out whether something is connected in series or in parallel, you can simply remember or recognize the pattern. That's the easiest way to go through the problems in at least at this level of the course. Now, if we are going to concentrate on the right side, if we're going to concentrate on the right side, we can also, with the same logic that we applied to recognize the connection patterns of the left side, we can say, look at R2 and R3. R2 and R3. First of all, they share a node on one side, and they also share another node on the opposite side. Remember, this is the definition of two resistors in parallel. One more time. When two resistors share a node on one side and another node on the other side, the pole of the resistor, then the two resistors are in parallel. Same way, you can see they share one node on one side here and another node on this side here. So obviously, this representation is easier to recognize as in parallel than this representation, but it would be your responsibility to recognize the way they are connected. We're going to do this because we are going to apply both the voltage divider and the current divider as part of your learning in the first half of this course leading up to the midterm exam. So let's have a look at a different diagram here. I can assure you that the left diagram and the right diagram are identical. If you build them, they will be the same circuit. The circuit will do the same thing. Now, let's go very quickly and apply our color coding. I'm going to start with the orange one here first. So I'm going to, from the positive to R1 and R3. Same, I'm going from the positive to R1 and R3. That's your one node right there. And then we have a different node that goes between R1 and R2, which is here. And then a different node, I might run out of colors here, but and then a different node that goes from R3 to R4, right? And another one that goes back to the negative of the power supply from R2 and R4. As you can see, these two circuits are identical. However, we didn't discuss whether the resistors are in parallel or are in series. Well, let's have a look. R1 and R2 if you look at R1 and R2, what I would notice is that everything that goes through R1, the current I1 that goes through R1 in its entirety must go also through R2. So if I1 and I2 are the same and equal, it means that R1 and R2 are in parallel. The same logic applies to I3 and I4 are the same and identical. So it is safe to say R1 and R2 are in series, R3 and R4 are in series. What that leads to is a diagram like this. This would be the equivalent, so would be R1 and 2, and this would be R3 and 4. And when the resistors are in series, we simply add them together as in addition, two numbers of the same type. So once we have this, what we can do is we can treat them as two resistors in parallel. So if you see a diagram as in this shape, you should be able to apply the nodes principle to figure out which resistors are in series or in parallel with each resistors. I would like to represent a slight variation here from what we just discussed. So if you look at, let's have a look at these two. We just said that those two are the same. But what happens if I add a wire between this point and this point right here? I'm going to get this guy here, which is identical to this guy here. You can simply apply the node analysis and see if these two are the same. Now, then the question becomes, R1, when we're talking about these two, is R1 and R2 in series? Well, let's have a look. R1 has I1 that goes like that, and R2 has I2 that goes like that. I can tell you right now that I1 and I2 are unlikely to be the same. Why? Because of this point here, that branch right there. What will happen is I1 is going to come here and then separate into two different kind of flows. The single flow of I1 will separate into two. Same with this guy here. It's going to come down here and it's going to go right there. Now, it doesn't mean that I1 and I3 are going to, fight against each other. Well, technically they will, but one of them will win. But don't forget that this is not necessarily a path. It could be a single point. So what I'm saying is, it is possible that R1 and R3 would be connected like this to a single point from which R2 and R4 are coming out, like so. So this would be 1, 2, 3, and 4. That's a third representation of the same circuit. It would be, again, it would be your responsibility to identify which resistor is in parallel or in series with which resistor. So if we just very quickly go back, I'm going to kind of delete everything that I have here. If we very quickly go back and look at the nodal analysis, if you don't mind. So we have one node here. This is the blue node. And we have a red node right here. And I'm going to make this green just to make it a little bit different. Now, wouldn't you say that R1 and R3 share one node at one end and another node at the other end? Well, obviously, yes. The answer is yes. Now, same thing here. If I go and do the same thing, this is the blue node right there. This is the red node right there. And this is the green node right there. As you can see, on the left side or on the right side, R1 and R3 both are in series, and the same applies to R2 and R4. They are R2 and R4 are also in parallel. So 1 and 3 are in parallel, 2 and 4 are in parallel. What we had before is 1 and 2 were in series, 3 and 4 were also in series. As you can see, things can get a little bit complicated, but please keep applying the same rules of the nodes, and you're always going to get the same results.